Okay, so we're now on page number 10, your textbook. If you were working in groups, I think this is a great idea. One of the best kept secrets, I don't know if this is a kept secret, in college to success is working with your fellow students in a group. You can struggle together, you can cry together, you can uh, talk about how awful your professor is together or how great they are, whatever it may be. So this is a great idea. If we were in person, I would be putting you in groups, although with the COVID world, you're not really, I have some online or some in-person classes, and we're not really in groups because we're following that 6-foot rule still. But it's the ability to talk to each other and work through the problems is the best way to do math. So please try to do that if you can. All right, so we're going to look further into this idea of giving 110% effort. So first, explain why a lot of people feel like that saying doesn't really make sense. Well, if I'm giving 100% effort, how can I then give 10% more, right? I'm giving all that's possible. There's instances, and it can be bad in the sports world, where athletes are being pushed by their trainers and working out, and if they've pushed too hard, the body shuts down. There's a case just last week, a student died, a wrestler, of heat exhaustion because he was pushed too hard and then no one took care of him. So that's why it doesn't make sense to give 110% effort. You can't give more than you have. That doesn't mean 110% is a meaningless number. We could calculate profits as 110%, or we could calculate, say, the number of calories you need to eat, or how many calories you ate in a day for a recommended diet. So it's still 110% can be useful in other cases. So we're going to convert this thing to a decimal. Well, that's what we learned in the previous videos. We moved the decimal 2 places to the left, 2. So 110% is really 1.1 as a decimal. We're then going to multiply that by 200, and that's going to tell us what 110% of 200 is. So I'm going to do 1.1 times 200. Turns out this is, let's see, 2.2. Wrong. Who said 2.2? This is 220. So if you think through what's happening here, this 1 was the 100%, right? And this 0.1 is the 10%. Well, 100% of 200 is 200. 10% of 200 is 20. So 200 plus 20 is 220, and you just saw an example of the distributive property. Not super important, but kind of fun. All right, so now let's put this into context. Suppose a normal half hour of practice, a tennis player expends 280 calories of energy. How many calories would she, or this particular tennis player, need to expend if she were to give 110% effort? Well, we're going to do exactly what we did up here. We convert this 110% to a decimal, that's 1.1, and then we'd multiply. I'm very happy to use Desmos for this. So get ready, here it comes. So 1.1 times 280 gives us 308. They would have to expend 308 calories if our definition of giving 100 of effort was the number of calories of energy burnt. I should be careful here and make sure I add in the units on this particular number. Okay, so let's check some other examples of how we could use these problems. So here our author, I actually met the author and his wife. This is the lady sitting here. Our author says that she really enjoys spending. So she found this red dress with a selling price of $79, and she had 2 coupons to use. One was just a flat $15 off a purchase of $50 or more, so the $79 meets that. And the other was to take 20% off, and we're to decide what's the better option. Well, our author, instead of just guessing at it, says, well, let's first figure out what's 20% of $79. Well, remember, to calculate this, we're going to convert our percentage to a decimal. That's 0.2. And then the word of means multiply. So we're going to do the decimal version of the percent times 79. That is 0.2 times 79. So here comes 0.2 times 79. And we get $15.8. So if our author used the 20% off coupon, they would save $15.80. Well, our author says, keeping in mind that you just found the amount the price would be discounted, which coupon should Cat have used? The name of his wife. Well, all we have to do is compare which one saves more, $15 or $15.80. Well, it's the 20% off in this case. 20% off because you save an extra 80 cents. There's another way we could have solved this problem. We could have said, what percent of 79 does the 15 represent? In other words, what percent discount is that? So take the total, or take the part, which is the $15, divided by the total, and we would get the percentage. So that's 15 divided by 79, and we get a number approximately equal to 0.18987. As a decimal, or excuse me, as a percent, we'd multiply this times 100, and we'd get this percentage. Oops, I didn't show you what I wrote. So 18.987%. Notice that's almost 19% if we rounded to the nearest whole percentage, which is still a little bit less than 20%. Okay, the last question here. Well, sales tax is 6.5. I believe the author lives in Florida. Last, when I met him, he lived in Florida, and that was about 5 years ago, I think. Michigan sale tax, I believe, is 6%, so a little bit less. So find the amount of tax on the dress purchased after applying the coupon that you chose and the total cost including tax. Okay, so remember that the original cost was this. Our discount was $15.80 off. So here's the price we would pay before taxes. Now, I don't know if you remember how to do this mess. You do this whole, 0 and 0, and then we're going to borrow 1 from here, make this a 10, so that's a 2, and then 8 minus 5 is a 3, and 7 minus, okay, 63.20. That's how much we would pay. But then we need to add in 6.5% of that. So let's calculate that by multiplying 0.065 times the total and getting that amount. 63.2 times 0.065. That's 4. So let's keep it exact. 4.108. Which you want to bet they're going to charge you $4.11 tax. So we need to add that in to the original price of our thing, and we get 8,037. Most likely you would pay $67.31. If you're paying with a credit card, they could charge you this. If you're paying with cash, they couldn't, because we don't have physical money for the to account for 0.8 cents.